This is Mr. Gluck again. I'm going to do some of the problems from the section 10.4 homework. That was a Dumov's theorem and the nth roots. I'm going to do numbers 4, 5, and 8. I think that's a good way to cover all the bases from what we did on Friday. So on number 4, we have this ridiculous looking polar form of a complex number here, all raised to the 12th power. Again, if we didn't have Dumov's theorem, we'd have to actually multiply this by itself 12 times, which would be awful. But Dumov's theorem says just take this to the 12th power. Again, I'm using the smart slate, so I have to write kind of small or kind of slow here. Take that to the 12th power, but then just multiply by 12 for the angles. Okay, so off to the side here, I'll do the cube root of 4 raised to the 12th power. Well, that means 4 to the 1/3 raised to the 12th power. And you would multiply the 1/3 times 12, and so you're really getting 4 to the 4th here. That ends up being 256. I had to check my answers there. Okay, so we know we have 256 to start off with. And now all we do is multiply 12 times 7 pi over 36. You take the power and multiply it by the angle. Again, it's kind of doing one operation backwards of what you would think. This can reduce to 1/3 there. So that'll make it a lot easier. It ends up being cosine of 7 pi over 3 plus I sine of 7 pi over 3. And now, final thing, we've actually completed it. This is in polar form, but we still need to get in rectangular form. All we have to do for rectangular form is go to our, let me get a black pen, go to our unit circle and figure out what the sine is of 7 pi over 3 and the cosine of 7 pi over 3. Well, that's a little more than a full rotation, but that's not going to be a big deal. So this would be exactly the same as 14 over 6. That's a 6. So this would be 1, 6, 6, 3, 6, 4, 6, 5, 6, 6, 7, 8, 9, 10, 11, 12, 13, 14 over 6. So basically all I have is my, bad right triangle. I'm going to undo that. I don't like that at all. Try that again. A little bit better. Okay, so I have my 60-degree reference. This is the root 3 over 2. This is the 1/2. So my cosine is 1/2. My sine is root 3 over 2. And remember, you're multiplying this, you're distributing that 256 into both of them. So the final thing would be to multiply that and that by 256. Remember, there's also this I on this one. So then your final answer becomes 128 plus 128 root 3 I. And there you go. There's a rectangular form for that number, which again, this was a little bit of work, but it was a lot easier than taking that original number up here and raising it to the 12th power. Okay, so the next one we're going to do is number 5. We have to do a conversion first. Okay, so for number 5, we're going to convert it to polar form first, then use Dumov's theorem. And then we got to convert it back to rectangular form. So again, the whole point of converting it to Dumov's is that we have that much easier formula. I'm sorry, converting it to polars so we can use Dumov's. Sorry about that. So I've got to convert this, I'll just keep circling this so it makes you busy, into polar form. It's actually not terrible. Well, it's 1 minus I, so that means go right 1. Oh no, I'm going to have to redo that one. I'm not very good at straight lines on this. Go right 1, down 1. And there's my right triangle. There we go. Okay, so 1, 1. That's a 1. Okay, so I have to get, for the polar form, remember I have to get the radius, also called the modulus or absolute value, how far away it is from the origin, and I need to get the angle of rotation to that spot. Well, since these are both 1s, this is a 45, 45, so 4, 5, 4, 5, the answer is about to arrive. Use root 2. Legs are same. So all you do is you multiply a leg by root 2, which just gives you root 2. So that is going to be my radius that goes out in front on this one. And then remember, you just kind of stamp in the cosine plus I sine stuff. Let me add that in. Cosine plus I sine. And I just need to figure out the angle. Well, the question is, what is the angle of rotation from there all the way to there? Well, that's 7 pi over 4, because it's 45, 45. So what goes in there is 7 pi over 4. 7 pi over 4. Okay, so what I've done is, all I've done is converted this rectangular number here, ignore the 12 for now. I've converted this rectangular number into polar form. Now I can raise this to the 12th power using de Moivre's theorem. So I'm raising this whole thing to the 12th power. So this would be 2 to the 1/2 to the 12th. That means 2 to the 6th. So again, this would be 2 to the 1/2 raised to the 12th. So that's 2 to the 6th, because you multiply those together. 2 to the 6th is, let me double check, that would be 64. So I've got my radius. Then again, according to de Moivre's, I just take that 12 and I multiply it by the angles. And so now that can reduce to 3 over 1 for both of these. And so it really becomes 21 pi. So this, let's see if I can be fancy and do this. There we go. So really it's cosine plus I sine of 21 pi. 21 pi. Okay, now, oh my gosh, 21 pi, that's a whole bunch. Well, it's not a big deal. It's just a lot of rotations around. So where is 21 pi on the unit circle? Well, pi, 2 pi, 3 pi, 4 pi. So every even you're getting here. So 2 pi, 4 pi, 6, 8, 10, 12, 14, 16, 18, 20, and then one more. That's where 21 pi would be. So what are the coordinates of that point? Well, those are -1, 0. So the cosine, remember, goes cosine, so the cosine is -1. The sine is just 0. So really we don't care if it's 0i, but it's just going to go away. So all I'm really doing is multiplying 64 by -1. And you end up with just -64. And it seems like a somewhat of an odd result. 1 minus I raised to the 12th power, multiplying that, foiling it a whole bunch of times over, will actually just give you -64. Kind of a bizarre result. But there it is. Okay, next one we're going to do is the last one, number 8, which is the one that a lot of you in class were kind of upset when I did that problem because it takes a while. Okay, now for number 8, last one. X to the 6 plus 729 equals 0 in the complex plane. We talked about this in class. We're going to end up taking the 6th root. So really what this means is, if we were to solve this like it was a normal equation, we'd say, okay, so x to the 6th equals -729. And then you would take the 6th root, and so you'd get x equals the 6th root of -729. And again, if we were just discussing the real numbers, you would say, oh, we're done. Even if you were in Algebra 2, it turns out that the 6th root of 729 is 3. So you'd probably say plus and minus 3i. It turns out that those will be some of the answers, but taking the sixth root will give us actually 6 answers. We mentioned that in class. So there are actually 6 distinct answers to this problem. To figure out what those answers are, we have to first convert -29 into polar form again, and then we can use the equation. It's not de Moivre's theorem, but it's basically the undo of de Moivre's theorem. And not to sound cryptic there, but first thing, got to get this in polar form. So it's actually not a very difficult one in polar form. Well, where is set -729 on the real imaginaries? Well, it's just back here, a distance of 729. And so your radius, so in polar form this would be 729. Then again we just stamp in the cosine plus I sine. And now we have to know what the angle is. Well, don't overthink it, it's just how far is that in radians. That's a pretty good arc for my smart slate stuff. Anyway, sorry. It's pi. Not a bad pi symbol there either. Okay, so I've got -729 converted into polar form. I'm doing the 6th roots of this. Again, the equation we had in class looked pretty daunting, but you're really just undoing de Moivre's theorem. You're doing it backwards. So I take the 6th root of 729. That's the first thing to do. And again, I mentioned the 6th root of 729 ends up being the number 3. Gave you a nice easy one. Like in class we had 2, but now we have 3, so pretty good still. And now, again, I'm undoing de Moivre's. Well, de Moivre said to multiply this by the power. The reverse of that would be then simply to divide it by the root. Now remember, there was a lot more that was attached to it because we have to account for 6 different answers. Again, we're taking the 6th root, so there's going to be 6 different answers. So I still have my cosine. Notice I'm leaving a pretty good amount of space here. Plus I sine. And I'll leave a considerable amount of space again. The formula we had, and this is to account for the amount of times of rotation and all that 2 pi stuff it takes to get to the same place. It's going to be pi over 6, which is what we had up here, plus 2k pi over 6. This is the master copy, if you will, the shell of all of our answers that we're going to find. So let me try to be fancy here and clone this. There we go. Easy enough. Okay, so now I need to actually get the answers. Again, this is the shell of the answers, but it doesn't give me actually the final answers. And again, on this one, notice that we have to get it in rectangular form, so we have to convert back. Since we need to get 6 answers, and again, we talked about this in class, we start with k equals 0. This k here equals 0, and we go all the way up to k equals 5. So we're just going to start hammering through all these. So the first one will be if k equals 0. So if k equals 0, that's the easy case because pretty much this will all zero out. So you're left with 3. I'm going to put a little trick in here. To abbreviate cosine plus I sine, some books just do CIS. Cosine, I, sine. This is not some fancy new trig function. It's just an abbreviation that's used. So just so I don't have to write it as much. So there you go. For k equals 1, again, I have the 3 out in front. Again, I'll just abbreviate with CIS. If I plug in 1 here, this would be 2, 6, plus 1, 6. So that would be 3, 6, which would just be pi over 2. So it reduces down to pi over 2. K equals 2. 3, CIS. If I plug in 2 here, this would be 4, 6, plus 1, 6, so 5 pi over 6. If if I plug in k equals 3, notice that the radius isn't changing. That's still at 3. That's constant. So if I plug in k equals 3, this would be 6 over 6 plus 1 over 6, which would be 7 over 6. K equals 4. Still got the 3 out in front. Cosine plus I sine. If I plug in 4, this would be 8, 6 plus 1, 6, so that's 9 over 6, which would be 3 pi over 2. Hopefully if you're doing notes diligently Friday, you'll notice that this is actually the exact same stuff here that we had on Friday. And then the last one would be k equals 5. 3 cosine plus I sine. If I plug in 5, I'd have, let's see, 10 6 plus 1 6, which would be 11 over 6, so 11 pi over 6. Okay, you've got all 6 answers. These are the 6 solutions in polar form that solve this equation in the very beginning. The last thing to do is to convert these into rectangular, and it seems tough. Oh, I've got cosine plus I sine. Again, I shortened this, but realize that this is cosine plus I sine for each one of these, and the angle's pi over 6. Well, you're going to notice that there's a pattern, particularly with this one, this one, this one, and this one. The first, third, fourth, and sixth ones. They're all 30-degree reference angles. That's in the first quadrant, that's in the second quadrant, that's in the third quadrant, that's in the fourth quadrant. But they're all 30-degree references. So really I'm just basing this off of a 30-degree reference. And so you go, okay, well, what would be the cosine? Well, that would be the adjacent, the root 3 over 2. What would be the sine? That would be the opposite, 1/2. So I'm doing the cosine of pi over 6, which is root 3 over 2. Notice that I'm timesing it by 3, though. So let me write this first one out, and then the next ones I'll just write down the answers, because we'll start to see the pattern here. So this would be 3, and then again the cosine of pi over 6 is root 3 over 2 plus the sine of pi over 6. Again, there's that I sine, so sine of pi over 6 is 1/2, and we've got that I on there. So if I distribute the 3 through, nothing really cancels, but I just end up with 3 root 3 over 2 plus 3 over 2 I. You go, oh my gosh, I got to do that 5 more times. Well, again, for all of these, it's just that the signs are going to change. In the second quadrant, it's going to be the exact same thing, except that the cosine, so I'll just put this in another color up here, the cosine is going to be negative. So the first thing would be negative. So this answer ends up being, actually I'll just keep it that color. Okay, so in this quadrant, the cosine would be negative, so that is going to be negative 3 root 3 over 2 plus 3/2 I. Down here, this is in the third quadrant. They're both negative in the third quadrant. Both the cosine and the sine are negative. So you're going to get the same answer, except they're both going to be negative. So this would be negative 3 root 3 over 2 minus 3 over 2 I. And then down to this last one, this is in the fourth quadrant. In the fourth quadrant, let's get another color. We'll go with a darker blue. In the fourth quadrant, the cosine is going to actually be positive. The sine's going to be negative. So this one will become 3 root 3 over 2 minus 3/2 I. And we can actually just write that, kind of a lazy mathematician way to write that, is just to say, okay, well I really have positive, negative, negative, positive. I really have every combination here. of positive and negative. So you could just write those answers plus and minus 3 root 3 over 2 plus and minus 3 halves I. That accounts for those 4 answers. The last 2 answers are actually easy to get. I saved the easier part for last. This is at pi over 2. Well, you say, okay, well, at pi over 2, what is the cosine? Well, it's 0. What's the sine? It's 1. So this means at pi over 2, it's going to be 3 times the cosine is 0, so 0 plus 1i, which really becomes 3i. And we mentioned that way back in the beginning of this problem. That was going to be one of our answers. Down here on this last one, I do the same thing. Well, 3 pi over 2, cosine is still 0, sine is negative 1. So it's actually going to end up being 3, 0 minus 1i, which will become negative 3i. So my last 2 answers, 1, 2, are the ones we thought from Algebra 2 that we would get. Plus and minus 3i. And again, that accounts for 6 different answers. What this all in the end means is if I took any one of these 6 answers, there's really 6 numbers here, and I raise it to the 6th power, I would get right back to the number negative 729. Kind of a bizarre result, but there are 6 answers there. Hopefully this helped, and we'll have a quiz on Wednesday, a test on Friday.